and 5 are the same, except there's a part B. Question 2 and 6 are the same, exactly the same, actually. Question 3, compounded monthly, and 7 is the same. So instead of 8 questions, I think you had half of that. All right, so let me do one, because one had part A, part B. So we started talking about A meaning the money you have in your account. This is the principal. 1 plus the rate divided by the number of times compounded, and again, the number of times compounded times the number of years. There. So I guess we found out some new buttons on the calculator today, right? So I think that's the most exciting thing. So number one, that's number one. It's $1,000 and invest $1,000. So that's my principal. And it's a savings account and it's paying 1%, so 0.08. And it's compounded. So question A, 1A, I should write 1A. It's compounded annually. So 0.08 over 1, and then 1 times the number of years, which is 10 years. Notice that we actually have to write the 1 and multiply 1 times 10. So I'm actually going to write 10 here. All right, so that's part A. And then over here, I'm going to even take that out. Make ourselves. So this is compounded annually. And then part B says monthly. So let me do it side by side. So A, the amount of money you will have, if you put $1,000, 1 plus 0.08, and this one, the monthly is compounded 12, so it's 12 times a year, and 12 times 10, which is the number of years. So that's the monthly and that's the year. That's the difference. All right, let's do the left. It's 1 plus 0. So if you add these two, you get 1.08 to the 10th power, which is what I'll do first. All right, so in the calculator, 1.08 raised to the 10th power equals, and I'm going to write with the calculator. I mean, you don't have to write all this, but I'm going to write because so everybody's on the same page. So 2158924999997. So that's what's in my calculator right now. Times 1,000, and it's therefore the amount of money that I'll have in my account after 10 years is going to be this much. Compounded annually. Now compounded monthly, let's see what the difference is. So 1,000, and here I'm going to divide 0.08 divided by 12, right? And then I'm going to add it to 1 plus 1, and we're going to get this very ugly number, right? And like I said, if you had this in your calculator, again, you would just press keep going, right? Continue, right? You don't. So I'm going to write what I have in my calculator. And then this is 120 because 12 times 10. So I'm going to press in my calculator. So I have this number in my calculator currently. I'll raise it to the 120th power. And in my calculator, I see 2.219640234. Multiply that by 1,000, and I get 2,219.64. So you can tell that compounding and monthly, look, you get a little bit more. And that's just with $1,000. Right? 2. Yeah, let me write it again. What is this? 1 plus R over N, and then NT. Number 2 says you want to how much should be invested, right? So P is what I'm going to be looking for, the principal, right? How much should I invest? At a interest rate of 5.5, so 1 plus 0.05 for 20 years. And this is compounded quarterly, so we're going to divide this by 4. And over here, 4 times the number of years, 20. And you want to have $1 million in your bank account. So there's your. So in order to have $1 million in your account, all right, and you put that money in a savings account or something, right, that pays 5% compounded quarterly 4 times over a period of 20 years, how much money? What should your principal be in order for you to walk out of there with $1 million? Well, let's simplify things that we can. 1 million equals P. And inside here, 0.05 divided by 4 is 0.0125, which we're going to add to 1. So I'm going to get 1.0125 raised to the 4 times 20 is 80. Right, so I'm going to, my next step in my calculator is going to raise that number to the 80th power, and I get 2. So this is what in my calculator, 2.714844941, and then we're going to divide both sides by that ridiculous number. And again, I don't want to round because again we want to be as precise as we can. Yeah, 1484941. So these two simplify to 1. P is all alone by itself. So I'll go 1 million, 123, divided by 2.701484941. Enter. It's going to give me this number, 370,166.79. So that's how much money you should invest in this account that pays 5% compounded 4 times a year. Leave it for 20 years, and then you walk out with $1 million. Next. So, what are we on? 3? 3 says, what is the interest rate? So R, this guy here, and I'll highlight it. Right, this is going to be our variable that we need to solve for. So, what interest rate, compounded monthly, must 4,000 be invested? So 4,000 is our principal. For 5 years, so 1 plus R, I don't know. Compounded monthly, so it's going to be divided by 10. And over here is 12 times, how many years? 5. And we want the account to have turn into 5,500. So the story is, you deposit 4,000, it's going to turn into 5,500. It's compounded monthly, 12 times a year, for a period of 5 years. In order for that to happen, what should your interest rate be? Well, let's do what we can. 5,500 equals 4,000. Over here is 1 plus R over 12, and 12 times 5 is 60. Next step, well, I can't do anything with this parentheses, so I'm going to divide both sides by 4,000. That simplifies to 1. So I'm left with that raised to the 60th. And over here, I have no idea what that is. 5,500 divided by 4,000. It's going to be 1.375. So how do we get rid of that 60 there that's bothering everyone, right? So this is the problem where you're going to take the 60th root, this side, and if you take the 60th root of the left side, this and this can go away. And that's going to allow me to finally not having to deal with that 60. So that's gone. And then so on the left side, you need to find, so you need to have this shown, this in your calculator, right? So and then you press enter. So how do we do that? So first, here's the order. Press 60. Second function, right? 60, second function. So actually, yeah, 60, second function, and then you're gonna press the arrow that points up. So right now, after you've done step 1, step 2, and step 3, your calculator should be, you should have something that looks like this, and a little square inside blinking. Now you get to put the number. The number you're going to put, well, it's 1.375, 1.375. And press enter. So the number is, and that's an approximate, right? Because I don't think it's an exact number. It's going to be 1.00532167. Okay. Well, now it's just an equation, right? We want to isolate r, so we're going to subtract 1 from this side. We're going to subtract minus 1 on this side. 1 minus 1 goes away. I'm fine left slowly with only r over 12. And on this side, if I subtract 1.00532167 minus 1, I'm left with 0.00532167. Last step, right? How do I make that equation look like this, where r is all by itself? Well, I multiply this side by 12. That simplifies. So if I multiply the right by 12, I must multiply the other side by 12. So multiply that. So we get 12 times 0.00532167, and that's going to give us 0.06386064. So if you multiply that by 100, it becomes 6.386064%. On the test, only ask it around to the nearest hundredth. Okay, although please understand that these two are not the same. It's rounded, right? I mean, that's just for us to simplify our answers, but it does that difference makes a difference in the long run. So that's number 3. Now we're doing 8. 8 is a time problem, so you're going to need the log. How long will it take for an investment of 1,000? So if you put $1,000, how long will it take to double it? So in order to double, so when it doubles, it becomes 2,000. Let me write again, A equals P 1 plus R over N and T. Right, so the principal is 1,000, compounded 0.05 and compounded annually over 1, right? And n times t, or sorry, 1 times t, which is just t. So 2,000, again, I substituted my values, 1,000. So I'm going to divide, well, 0.05 divided by 1 is just 0.05 plus 1, so I get 1.05 raised to 1 times t is just t. All right. So divide both sides by 1,000. Right, basically telling you it's going to be a factor of 2 here, right? And then here we get 1.05. Now we can use log here. We can take log both sides, so we can say log of 2, log of 1.05t, right? And again, what that allows us to do, let me write log of 2 again, is that this exponent can come up with it. So we get t log 1.05. Now that becomes just an equation. So how do I isolate t and have t by itself? So how do I make this equation that looks like this look like t equals some value? I'm going to divide this side by log of 1.05. Divide this side by log of 0.05. Notice that the base here, right, because I didn't write a base, log base, it's base 10. Okay, so now in your calculator, this one is easy. So let's see, second function, so let me go through the process. First of all, you're going to press this button, right? The N over D, so your screen should look like this, right, blinking. So you're going to be on the top, you're going to press second function, PRB, and then you're going to press number 1 for log. And then you'll see that it says log parentheses, and you're going to see it blinking, right? So you're going to put the 2 there. So you're going to put log and says parentheses and it's blinking, so you go log of 2 and you can close parentheses. So the top of your fraction looks like this now. Right, top of your fraction looks like this. Now move your cursor down. Same thing. Second function, PRB. Press 1, and again you're going to have this blinking right now on your screen, so you have this and it's blinking, and we're going to put 1.05 and close parentheses, 1.05 close parentheses, and then equal sign, and we get enter. We get 14 point, I don't know, 14 point rounded, I guess, right? 21 years. All right. Okay, and then I don't know. Let me see if I can explain log of 2 for again. Remember, log of 2 basically, right? Well, there's an invisible 10 here. It's asking 10 to what power equals 2. That's what it's calculating for you, right? And if you just, let's just play with that. Let me find out what log of 2 is for you. And second function PRB 1, and you press 2 and you press enter. The calculator is going to tell you that the log of 2, right, is 0.303010299996. And probably continues on, right? So the answer to log of 2 is this. So 10 to this power over here equals 2. And if you don't believe me, go on your calculator, press, go 10. So you're going to go to 10, you'll put the arrow that points up. Sorry, you're going to go 10, yeah, arrow that points up, and you're going to enter 0.3012996. Press enter. And again, you're going to get a value, right? That is very close to 2.00124195, etc. Like I said, look, it's close to 2. Obviously, it's not going to be exact, right? So that's what log of 2 is. And the same thing for the other one, log of 1.05, what the calculator did for you, right? So log of 2 is this value, so we took 0.03010296 and we divided by log of 1.05, and again, log of 1.05, so 10 to what power equals 1.05. And I guess I'll do it. Second function probability 1.05, enter, and that value is 10 to the 0.0211892999. That's the answer. So when you were dividing here, when the calculator, I should say, was dividing for you, calculator was dividing log of 2, which is 0.301029996, and again, a bunch of more numbers, over 0.0211892999. That's how we got 14.2. All right, am I done? No, I have one more. 5. Why did I skip? No, 4. How long will it take for an investment? So again, an investment of $1,000. To double, you want to make it 2,000. Let me do this. And it's compounded. It's 5%, so 0.05. Compounded weekly. How many weeks in a year? 52. There's 52 over here. And then 52 times t. Right, 52t. That's our problem. All right. So what can we do here? Let's simplify this a little bit. We can right off the bat, if you want to, divide by 1,000 each side, right? So you get 2 equals, and let's simplify inside the bracket. So that goes away. And let's divide, so let me put in parentheses, actually, let me do 0.05 divided by 52, that equals, and then we're going to add it to 1. So if you divide 0.05 divided by 52, you get this, 961,538, and then you're going to add it to